Okay, what's up, warriors? We're going to continue where the last video left off and do some calculations. So what I want to do is I want to figure out the z-score where we left off last time. Just so what we're looking at is we're looking at the p-pop equals 0.8. That was given to us. We also have our characteristic of interest was 10, and our n was 50. And so based on that, we know that p is equal to 10 divided by 50. Now, I know what you're thinking. You're probably thinking, well, I can figure all this out on a calculator. I can figure this in the red here on a calculator, so why would I want to put it in Excel? Well, two reasons. One is so you can lay it all out nice and neat, and that this kind of computation here in the denominator is not going to mess you up. But more importantly, we want to be able to establish a model, just a little simple model. Some people call it cell referencing. I like to kind of jazz it up a little bit and call modeling like a mother, kind of like Samuel Jackson would say. But the point is so that we can assess changes. And if things change, we can get past just the one problem of the red into, quote, modeling how things might happen based on other givens and things being constant. So let's talk about this denominator and how I'm going to put that in Excel. Well, I like to, at least until I get the handle of things, we could make a cell here that refers to all this other stuff and one big equation. And if we don't watch out, Excel would make us pay for doing that. So I like to go a little bit slower. First, I like to say, what is the denominator? I like to work my way bottom to top. So denominator 1 is just going to refer to that 50 there in the very bottom of the denominator. And I can grab it from there. And then denominator 2 is going to refer to the p-pop portion of that square root. So I'm going to take that 0.8, which is the p-pop, and I'm going to grab it from up here, and I'm going to, within the same cell, do a 1 minus of that p-pop. And that'll give me that number there. Now then, if I really want to be deliberate, I could take the denominator 3, which is that 0.16, divided by the 50. And then for the actual denominator itself, I won't put a 4 on it. I'm going to take the square root of that value that's above it. Okay? Now, to make it even simpler, I could do it another way. I could work my way truly bottom to top. So I could say denominator 1 is that 50. So here I'm working from here and working up. I could say denominator 2 is that p-pop times the 1 minus p-pop. That denominator 3 is the same way as I did it before. That's going to be this divided by that. And then the denominator itself will be the square root of that number below it. Okay? And of course, I'm still not at z yet. My z-score that will lead us to the probability of this sample proportion occurring with that given there. That z-score, this z-score, will be the numerator, which I haven't figured out yet. I'm just going to park the numerator right here for now, divided by the denominator. And the numerator, as we know, is that 0.2 p minus the p-pop. So I'm going to take my numerator divided by my denominator. And that should give me a negative number, which it does. Now, where the cells are and how you do this, that's all up to you. The point is, number one, we now are past the calculator. We can see all of our values, and then and we can get this PEMDAS complicated thing in the denominator correct and the whole thing correct. I just worry sometimes when we go in a calculator, we potentially could make some errors that we don't need to make. Excel allows us a lot more space to do what we want to do. More importantly, though, when n changes, we can assess the impact of that. We can assess if x changes. So if we did another sample and found that 30 people out of 50, well then that would be a different z-score, and maybe 40 people out of 50. So that would be right on the mean. We can see that proportion would be 80. Let's go back to 10 out of 50. And let's look at the impact of n changing. Now with the proportion, it's going to be a little bit different. Okay, so when the n becomes smaller in a proportion, then we'll get a different z-score. We're going to get a z-score that's not so far away from the p-pop. 0.28, not very far at all. We go back to 50, and let's say we go to 500. As n gets larger, we're going to get something that's much farther away, negative 43. Let's go back to 50. So we know the probability that negative 0.10, or excuse me, negative 10 is associated with is less than 0.0001 of a probability, because the z-score table begins at negative 3.6. So anything farther to the left is less than 0.0001 in terms of probability. So negative 10.60 is going to be way out there to the left. And we also know that if this n becomes greater, we're going to get farther out to the left. Conversely, if n becomes smaller, well, that proportion, that sample p, is going to become larger, which would make a smaller z-score and a greater probability. It's a little bit reverse. But the main thing is, even if we don't understand conceptually off the top of our head when dealing with proportions what the impact is of n getting smaller and larger, we don't have to. If we lay it all out in Excel, we can just play with it like a knob on a TV. Of course, I don't even know if we have knobs on TVs. When I was a kid, we had knobs on TVs. Okay, boomer. Anyway, so we don't have to memorize all that. We can just play with the numbers and go, oh, the smaller n gets, the more the z-score comes closer and closer. Now we know n can't be less than x in this instance, because that just wouldn't make sense. Excel will give us a number, but in reality that doesn't make sense. That means we surveyed 9 people and we got 10 responses. So that just doesn't make sense. The most that, and we see that in this value of P down here is 1.11. We have a proportion of 1.11. Well, in this context, that doesn't make sense. So N could be 10, but it can't be more than 10. Okay, could be 11, could be 12, could be 13, and so on and so forth. Okay, so I just gave you a 2 for 1. 1 is the value of seeing this answer in Excel, and 2 is the value of modeling these problems in Excel. And in a separate video, I'll look at the sample mean and how we do this with sample means. So that's it for now. On this video, the takeaway is how we determine if we have the sample, or excuse me, we have the proportion population. We have a sample. First of all, how we determine a sample proportion, which is x divided by n, and then how we compute a z-score for that particular sample proportion, and how we get a probability out of that. Don't forget that, of course, things don't change. So to get this probability would not be that, okay? To get this particular probability, if indeed our population proportion was 0.8 and our sample proportion was 0.769, let's just go with that for a minute, and let's use this z-score, negative 0.277, and we'll just round that to negative 2.8. So we would pull up our handy dandy z-score table. Of course, I don't always have it handy. Just bear with me. Here we go. And we're looking at a negative 2.8. So the value of remembering that first column, the 0 column, helps me just keep track, and I don't have to keep these numbers up on the screen. Negative 2.8. That's a 0 column, so 1, 2, 3, 4, 5, 6, 7. I'm going to go over one more, 8.3897. So much higher probability than we had before with 0.0001. And of course, it's the same rule applies. The probability that my sample proportion will be that, the probability of that occurring or less is 0.3897. The probability of my sample proportion being that or more is that 1 minus that value right there, which is that value. So that concludes our discussion of sample proportion probabilities. I gave you a little bit of bonus there, how to put it in Excel. But beyond the formula, P minus P pop divided by the square root of P pop times 1 minus P pop over the sample size. The process is the same. I get a z-score, and I go to my z table and see what that probability is.